All right, here we go with decimal expansions. Number one, what is the decimal expansion of the following fraction? You should know that a fraction is a division problem. And if you want to turn a division problem into a decimal, you could do long division. And you could do it on paper. And then after I do it this way, I'll show you how to check it with a calculator. But 1/9 is equal to 1 divided by 9. Now, when I was a little kid, I got taught the cowboy riding the horse, and then the cowboy is the numerator, the horse is the denominator. Obviously, the cowboy sits on top of the horse. The cowboy goes inside the building, and the horse has to stay outside the building. So if you get confused about which one goes on the inside and which one goes on the outside when you're moving from a fraction to long division format, that's a little mnemonic device I like to use. But here we go. How many times does 9 go into 1? It doesn't. It goes in 0 times. And you should remember that when it goes in 0 times, you write 0, you put a decimal point, and then you make it into a 10. Now you say, how many times does 9 go into 10? It goes in 1 time. And when you get a number up there that's not 0, you say 1 times 9 is 9. And then you subtract. 10 minus 9 is 1. And once you have a subtraction answer, you get another 0, and you bring it down if that answer is not 0, because you need to keep going until your remainder is 0. But now what happens? We have another 10 again. 9 goes into 10 once again. 1 times 9 is 9 again. You subtract, you get 1 again. You bring down a 0 again. You get 10 again. It's going to keep happening over and over again. So what will the answer be? It's just going to keep being a bunch of ones forever. So 1/9 is equal to 0.1 repeating. We put a little bar over it to indicate that it keeps going on and on forever. And that is A. Now I'm going to tell you right now, anytime that you have 0 point and one single digit repeating over and over again, it's just that digit over 9. That's all it's going to be. So 0.2 repeating is 2/9. 0.3 repeating is 3/9, which simplifies to 1/3. 0.4 repeating is 4/9. 0.5 repeating is 5/9, etc., etc. It's going to serve you well just to remember that, and you'll never have to do this long division ever again. You'll never have to punch it into a calculator. 1 divided by 9 equals, and see that it's 0.1 repeating forever. Just know that every time that you have a single digit, one little digit repeating, it's just that digit over 9. And you can simplify 3/9 or 6/9 into 1/3 and 2/3, but it's equal to that digit that's repeating over 9. Next question, number 2. Find the fraction equivalent of the number in simplest form. It's 1.235 repeating. So 1.235, 235, 235, 235. So how do you turn a repeating decimal into a fraction? There's a long way to go about it, but then I'm going to show you a shortcut. First, let's show you the long way. Now, the long way is a little confusing, but stay with me, because if it's the first time you've ever seen it, you're not going to have any idea what I'm doing, but I'll walk you through it, and then I'll show you the shortcut. So here we go. 1.235 repeating. Let's call 1.235 repeating x. So x equals 1.235 repeating. That's weird. Normally, we don't start with a variable unless our variable is a number we don't know. This time, we know the number, but I'm calling it x anyway, and you'll see why in a second. Let's say x is 1.235 repeating. Well, what would that make 1,000 x's? What would be 1,000 times x? Well, 1,000 times x would then be, anytime you multiply something by 10, you just move the decimal place over one spot, don't you? Well, if you're multiplying by 1,000, that's just multiplying times 10, times 10, times 10. So if you multiply by 1,000, you just move it 3 places. One spot would be multiplying by 10, 2 spots would be multiplying by 100, 3 spots is multiplying by 1,000. If I move this decimal 3 places, it goes on the other side of the 5. So I get 1,235, and then the decimal point. Let's not forget, this wasn't just 1.235. It was 1.235 repeating. So after this 235 comes another 235, and another, and another, and another. So after this decimal point, I still have 235s that are repeating forever. What was the point of that? Why does that matter? Here's why. I'm going to take my 1,000x, and it only says 100x. I'm going to take 1,000x, and I'm going to subtract my 1x. Well, what's that equal to? 1,000 x's minus 1x. This is not 1,000. 1,000x minus x is not 1,000. Remember, it's 1,000 x's minus 1x. If I have 1,000 of something and take away one of them, how many do I have left? I have 9,999 x's left. Well, what does that matter? Because I know what 1,000x is equal to. and I know what 1x is equal to, and watch what happens when I subtract those. 1000x is equal to 1235.235 repeating. And x is equal to 1.235 repeating. If I subtract those, what do I get? Well, what happens with 0.235 repeating minus 0.235 repeating? They cancel each other out and it becomes 0.0. No more repeating decimal. The decimals that repeat are gone. And then I simply have a 1235 minus 1, which is 1234. So the answers that I have here tell me something. If 1000x is equal to that much, and 1x is equal to that much, and 1000x minus 1x is 999x, and that much minus that much is 1234, then 999x is equal to 1234. And this is a really simple equation that you should know how to solve. If you have a number times x equals another number, what do? You divide by that number. This is a very simple one-step equation. It's got big numbers, but you know how to solve these. 999x divided by 999 is 1x. So 1x is 1,234 999s. Okay, so 1,234 999s. Well, why is that significant? Because we already knew that x was equal to 1.235 repeating. So x is equal to 1,234 99s. If I turn this this fraction, this improper fraction, into a mixed number, 999 goes into 1,234 once, so x equals 1, with what left over? What's the remainder? 235 999s. Hey, 235. Does that number look familiar? Sure it does. 235. It's the decimals, the three decimals that we're repeating. So we have 1 and 235 repeating. That turns into the mixed number 1 and 235 99ths. So what I'm telling you here is the shortcut. Just the last problem, I told you if you have one digit repeating, it's just that digit over 9. Well, if you have 3 digits and they're all repeating, then they're all over 999. Guess what happens if you have 2 digits repeating? Those 2 digits are over 99. Every time you have repeating digits, if all the digits are repeating, all of them, then however many digits are repeating, it's equal to those digits over the same number of 9s. So 1 digit repeating is over 9, 2 digits repeating is over 99, 3 digits repeating is over 999, 4 digits repeating will be over 9,999. So all you guys have to do is remember that for all these ones where you have digits where they're all repeating. Now, not every repeating decimal has all the digits repeating. Sometimes you have a fraction like 1/6, and 1/6 doesn't have all the digits repeating. 1/6 is equal to 0.1, and then just the 6 is repeating. A decimal like this doesn't fit our little pattern because not both of the decimal points after the 0 are repeating. That I'll show you how to do in a little bit. But if you have all the digits repeating after a decimal point, then all you have to do is take those digits that are repeating and put them over an equal number of 9s, and that's the fraction. Now, this problem is asking us to simplify that fraction. So it says, find the equivalent of the number in simplest form. I'll use my improper fraction. Do those two values divide by the same number? Do they share any common factor? So all you should do is figure that out, and you're good to go. Take the time to do that and look for it. You'll figure out that is the simplest form. You cannot reduce or simplify 1,234 over 999. It is an improper fraction you can convert to a mixed number, but you cannot simplify that fraction. Let's do another problem. What is the decimal expansion of the following fractions? So this time we have 1/16. 1/16 has nothing to do with 9s like the other problems we've been doing. So let's go ahead and do our long division. But then again, you can just punch this stuff into a calculator. But I'll show you with the long division anyway. 1 divided by 16. I just wrote that backwards. Let's try that one more time. Again, 1/16. 1 divided by 16. 1 on the inside, 16 on the outside. So 1 divided by 16. 16 doesn't go into 1, it goes in 0 times. So we put our decimal points 10. 16 doesn't go into 10 either, so I got another 0. So now I have to try 16 into 100. How many times does 16 go into 100? Well, 16 times 6 is 96. I know because 10 times 6 is 60, and 6 times 6 is 36. 16 and 36 is 96. So you got a 6 here. 6 times 16, 96. 100 minus 96 is 4. Bring your other 0 down, you get 40. 16 into 40 goes twice. 2 times 16 is 32. Subtract, and we get 8. Let's keep it going. We'll bring another 0 down, and we get 80. 16 goes into 80. Let's see, that is 5 times. 5 times 10 is 50, and 5 times 6 is 30. 50 and 30 makes 80. So 80, and when I subtract, and I get 0. When you run into a 0 for your remainder, you're done. This one is just 0.0625, and that is all. If you need to double check your answers, or if you want to do this more quickly, it's okay for you to use a calculator. We live in a day and age where we know you have a calculator on you all of the time. 0.0625 you can find by doing 1 divided by 16. Double check your work, you get 0.0625. Now, I could have done this problem without even looking at the long division or using a calculator, just by looking at the answers. And the way that I know how to do that is by process of elimination. 1.16, that's more than 1. This is not more than 1, so that's not the answer. A is not the answer. I know C is not the answer because I know this is not a repeating decimal. Why? Because the denominator only has factors of 2. And if the denominator of the fraction has factors that are only 2s or 5s, some combination of 2s and 5s, then it's going to be a terminating decimal. And I know 16 only has factors of 2. It's 2 times 2 times 2 times 2 is 16. So because of that, I know that it's going to be a terminating decimal. That leaves only B and D as my answers. And since 1/16 is clearly less than 1/10, and 0.16 is clearly more than 1/10, D is the only answer that makes sense. So some of these things you can answer without even doing the math. You could just look at the problems selections that it gives you, and you can do process of elimination. Let's do another. Use the following number to complete the statements below. We got 0.16 repeating. I just told you what this was in a few problems ago. The decimal above is a what? It is rational or irrational. Any repeating decimal is rational, okay? It's a rational number because it is a repeating decimal. Any repeating decimal is rational. That little line says it's repeating. The fraction equivalent of this number is what? So how do I turn 0.16 repeating into a fraction? Very simple. I'm going to use that same method that I did earlier. Now, the method I used earlier, I did it kind of fast. I didn't really explain what I was doing. So let me do that really quickly, and then we'll do it with the new number. And down here it already says the answer, but stay with me here. What did I do? I started off by saying that the number I was given was equal to x. Then I multiplied by 1,000. Why did I do that? Well, what I wanted was I wanted to move the decimal to the end of the repeating section. My goal here is to have one value times x that has the decimal behind the repeating section, and one value times x where the decimal's right in front of the repeating section. That way, the repeating sections cancel out. Now, this one was really easy because the original value did have a decimal right in front of the repeating section, so I didn't have to multiply x by anything for that part. But to get it behind the repeating section, I had to multiply it by 1,000 because I need to move it 3 decimal places since there are 3 decimals that are repeating. So how do I do it for this one? The way it works for this problem is I'm going to say that x is the number I was given, which is 0.16 repeating. Now I'm going to put the decimal point right in front of the repeating section and put the decimal point right behind the repeating section. So let's do it behind it first. I have to move it 2 spaces to do that. That means I multiply by 100. So I'm going to start with 100x, which is equal to, and if it goes right behind it, that becomes 16.6 repeating. So step 1, multiply so the decimal is behind the repeating section. Step 2, multiply so the decimal is right in front of the repeating section. That's multiplying by 10 because I only want to move it 1 spot. So 10 times x will equal 1.6 repeating. Now that I have 0.6 repeating for both of those, when I subtract both of them, the 0.6 repeatings cancel out, and I have 16 minus 1, which is 15. And that is equal to what I have over here, 100x minus 10x, which is 90x. After that, you should have a simple one-step equation. If 90x is equal to 15, then 1x is equal to 15/90. Just divide both sides by 90. And hey, 15/90, I can simplify that. 15 and 90 both divide by 15. 15 divided by 15 is 1, and 90 divided by 15 is 6. So when I simplify the fraction, I get x is equal to 1/6. And of course, x started off as equal to 0.16 repeating. So those two things are both equal to x. They have to be equal to each other. So in my answer over here, 1/6 is equal to 0.16 repeating. Let's do another. Use the given long division calculations to determine the decimal expansion of 7/9. Well, 700/9, if I do 700 divided by 9, 700/9 is 77. 7,000/9, 777. 70,000/9, 7,777. If you do 7 divided by 9, you're going to get a bunch of 7s. So that's what we should pick over here. The decimal expansion of 7/9 is 0.7 repeating. And like I told you right after the first problem, anything over a 9 is just that digit repeating. So 7 divided by 9, 0.7 repeating. 8 divided by 9, 0.8 repeating. Very simple. Let's keep it going. Consider the following decimal expansions. 1/99 is 0.01 repeating. 68/99 is 0.68 repeating. 3 and 82/99 is 3 and 82 repeating. So again, it's just the numerator repeating. And since it's 99 on the bottom, it has to be 2 digits. 1 is only 1 digit, but if you write it as 0, 1, all of a sudden you've written the number 1 as a 2-digit number, 0 and 1. And you see the 0, 1 repeating. So use the pattern above to determine which fraction is correctly converted into its decimal equivalent. Which one of these has something over 99 and it's those 2 digits repeating? 8 over 99. How would I write 8 with 2 digits? It'd be 0.8. 0.08 repeating. That's your answer. See, this one's wrong because it doesn't say 0.3 repeating. It just says 3 repeating. Well, 3 repeating would be 3/9, not 3/99. So that one's wrong. This one puts the 8 that's out in front on the wrong side of the decimal. So like that'd be kind of like if they put the 3 on the right side of the decimal instead of the left. That's all wrong. And this one, 76 over 99 is close, but they don't have the 7 repeating with the 6. It's just 7, 6, 6, 6, 6, 6, 6. Just the 6 is repeating. It should be 76 repeating. 76, 76, 76. A is the answer. Keep it moving right along. Which phrase describes the decimal expansion of the following number? Now that is pi. And you should have learned by now, you should have learned yesterday or before, that pi is a decimal that never ends and never repeats. Never ends means it's non-terminating, and non-repeating is never repeats. So if you multiply a non-terminating, non-repeating number by something else, you're still going to get a non-terminating, non-repeating number. So an irrational number that's multiplied by some other number is still irrational. So A is the answer. Let's keep it going. Number 8, what is the fraction form of the following decimal expansion? We just did a number problem that helped you with the pattern here. It's 0.81. 81 are both repeating. 0.81, 81, 81, 81. Those two numbers repeating. It's 2 digits that are repeating, so you put it over 2 9s. So it's 81/99. Notice that's not one of the answers because you have to simplify 81/99. 81 and 99, what do those both divide by? If I have the fraction 81 over 99, hopefully you recognize 81 and 99 both divide by 9. 81 divided by 9 is 9. 99 divided by 9 is 11. So 9/11 is your answer. Number 9, what is the decimal expansion of the following fraction? 1/10. You know what it is? It's 1/10. Which one of these decimals say 1/10? 0.1. Don't overthink it, people. Number 10, what is the fraction form of the following decimal expansion? This is 12.518 repeating. 12.518 repeating. Well, guess what it's going to start with? It's going to start with 12. It starts with 12 right now. It's going to start with 12 when we convert it. So now all I have to do is worry about the 0.518 repeating. So it's 0.5, and then just the 18 is repeating. So 0.5, 18 repeating. 0.5, 18, 18, 18, 18, 18. Let's use our little strategy to convert that 0.518 repeating. Here's how that works. If 0.518, so 18, repeating, if I call that equal to x, again, the strategy is put the decimal behind the repeating section, put the decimal in front of the repeating section, and subtract. Start with putting it behind it. Putting it behind it is moving it 3 spaces. So 1,000x, 1,000 times x is equal to 518.18 repeating. So that's 1,000 times x. So step 1 again, move the decimal so it's behind the repeating section. Step 2, move the decimal so it's in front of it. That's moving it just one spot to get between the 5 and the 1. So moving it one spot is multiplying by 10. So 10x is equal to 5.18 repeating. So 5.18 repeating. Now we subtract, and what do we get? 1,000 x's minus 10 x's is 990 x's. So 990 times x equals, over here, 518.18 repeating minus 5.18 repeating. The 0.18 repeatings cancel out. 518 minus 5 is 513. And now we have our simple division problem. 513 and 990. When we divide, we get x equals 513 over 990. And if we can check for if those simplify or not, we will get our answer. So what do 513 and 990 have in common? What factors do they both divide by? There is a little trick if these look like really big numbers that you should know, and it's this. If you take the digits of any number and add them together, and that divides by 9, then the original number divides by 9. So what I'm telling you is 513 is 5 plus 1 plus 3 with this little trick. 5 plus 1 is 6, 6 plus 3 is 9. Since 9 divides by 9, 513 divides by 9. What is 513 divided by 9? It's 57. Okay, so 513 divided by 9 is 57. You can check it with your calculator. Here's my calculator. 513 divided by 9 equals 57. So both of those numbers are going to divide by 9. If I look at the other number, 990, that clearly divides by 9. 9 plus 9 is 18, and 18 certainly divides by 9. So 990 is going to divide by 9. 990 divided by 9 equals 110. So we have 57 and 110. And that is it. Work hard and good luck.